Hello friends, today let's solve shopping offers. We are given some items and its corresponding price. And we also have a special offers, which means, for example, we can buy 3 item 0 and 0 item 1, and we only need to pay $5, so on and so forth. And we also have a needs list. That means we need to buy exactly 3 item 0 and 2 item 1. And we needed to output an integer, which means the minimum price or the minimum dollars we need to pay. We have the list of the items, a list of integers. That means item 0 it costs $2, item 1 costs $5, special offers, some list. And this needs also an integer list. So how to solve this problem? I think the solution is very intuitive. We just try all combinations. So it's obvious that we need to use backtracking. I think the difficulty is how to write the whole progress fluently and clearly. Let's see. First, of course, we need to maintain a global minimum price, because every time we find every time we find a combination that we can buy exactly the same needs, we get that price we needed, and we compare that price to the global minimum price, and we can, in that way, at last we can get the minimum price. So we can usually, when we need to calculate the minimum value, we usually initialize it to integer max value. But in this example, we can actually initialize it to that we buy all the items without using special offers. For example, we can first initialize this minimum price to 3 times 2 plus 2 times 5. Okay, then we also need to run a help function. Why? Because usually the reason we use a help function to do some recursive operation is that the parameters is different from the original function. So we write a help function. So let's see what are the parameters we needed for this help function. We need the price for each item. And we also need the special offer. And we also need the needs. We need to buy these items. And then we need an integer called use. That means the dollars we already used so far. Why? Because one thing is that if we find a useful combination, we compare this value with the global minimum price. Another thing is for pruning, because once this use is greater or equal than the minimum price, we just stop right here, because there is no need to keep exploring. And the index, what does the index mean? That means the index in the special offer, because we have many offers and we try everyone. And you can see it's like we can use this offer several times. So we need to record the current index. Okay, so for the base case, one thing is I mentioned before, once the use is greater or equal than minimum price, we just return. Another thing is we cannot use special offers anymore. That means the index is reach the end of this special. Once it is equal to special dot size, that means we are run off. We have finished using our usable offers. So in that case, if there are still some items we haven't bought, we just buy them directly. Actually, it's the same function here. Buy them without the special offers. The same thing. We accumulate this value to the used, and we compare this use with the mini price. If it's less than mini price, we update it. Okay, this is the base case. How about the recursive case? As we have the index of the special offers, we can get a current offer. But we need to check whether we can use this offer, because we can only buy exactly the same amount of items needed. If the current offer, it has more items than needed, we cannot use it. So if we can use it, we update the needs and after the used, this is the price we already pay. And we continue to call this help function. And you should notice that the index is still index. We did not increment by 1 because we can use the same offer several times. If we cannot use it, we should use the next offer. So we index plus 1. Okay. So wrap up. We just try all combinations. We need a global minimum price, and we initialize to buy them without special offers. We should write it as a function because we call it a second time. Okay. Then the help function. We need 2 parameters except these 3. Other than these 3 parameters, we need used for accumulate the dollars we use, and the index indicates the position in the special offers. Base case is if the use greater or equal than minimum price, we return. And once the index equal to special dollar size, we just buy the left items directly and compare this use with the mini price. Recursive case, get current offer and check whether we can use it. So in that place, we also write a function. Just check each item amount with the needed. So if we can use it update the needs and used, call help function. If we cannot use it, also call help function, but remember to increment this index. Okay, now let's write the code. First, I need a median price. Okay, median price equal to directly by price and needs. Call help function. Return median price. Let's write the directly by. So the first parameter is price. Second parameter is also integer. This is called needs. So get n of the needs. We also have total. Start from 0. So for int I equal to 0, I less than ni plus plus. Total will accumulate the sum. Price get I, needs get I. Then we return total. Okay, so now let's write helper. The return value is void because we already maintain minimum price. So first parameter, integer, price, and special, and needs. We also need used and index. Okay. The base case, if the use is greater or equal than median price, we just return. If the index equal to special dot size, we buy the left items directly. So directly buy price and needs. Do not worry because we always update these needs. So if this needs a use less than median price, we update median price to the used. No matter what, we still need a return because it is a base case. Otherwise, we get the current offer, which is the special get index. We check whether we can use this offer and needs. So now let's write this can use function. This is offer. We also have this needs. How to check it? Just check whether the amount exceeds the needs. So n is needs, not the offer, because offer has 1 element more than the needs. It means the price needed to pay. So needs.price. Okay. So for int I equal to 0, I less than ni plus plus. If the offer get I greater than needs, get I will return false. We cannot buy it. Otherwise, true. Okay, if we can use it, now we should get n. N is the needs dot size. Another thing is the integer list. We call it updated needs. Because if we use current offer, the needs should be updated. So we iterate all the items. So updated needs add, there should be the previous needs get I minus the offer get I, right? Okay, this is updated needs. So we recursively call the helper. The parameter is price special. Its place should be updated needs, and the used should plus. Why should we plus? Because we use this offer, so we should pay it. Get the n is a price. How about index? Still the same index, because we can use one offer several times. If we cannot use this offer, we need to move on to next offer. So it should be index plus 1. So we fill these parameters here. Price, special, and needs 0, 0. 0 use 0 index. Okay. Thank you for watching. See you next time.